How to find the N factor of an oxidizing agent or a reducing agent? An oxidizing agent gains electron to get reduced itself and oxidize other. For example, potassium permanganate and potassium dichromate. Whereas a reducing agent loses electron to get oxidize itself and reduce other. For example, ferrous sulfate. And the difference in charge in a chemical reaction is its N factor. KMnO4, the strong oxidizing agent in acid medium, turns into manganese ion. In the polyatomic molecule of the KMnO4, the oxidation state of potassium is +1, as only one potassium atom is there. And 4 oxygen atoms bear -8 charge. And to make the molecule neutral, the manganese is in +7 oxidation state. In acid medium, it turns into manganese ion with +2 charge. I am only speaking of manganese because it is only manganese undergoing change in oxidation state. Let me say again, the oxidation state of manganese is changing from +7 to +2, means it has gained electron and its positive charge reduced. So manganese is reduced by accepting 5 electrons and oxidize other substance in chemical reaction. Again, the charge on manganese is changed from +7 to +2. For N factor calculation, we consider only the mode value of difference in charge. So manganese is reduced by accepting 5 electrons and oxidize other substance in chemical reaction. So in acid medium, the oxidizing agent KMnO4, it has N factor 5. In basic medium, KMnO4 become K2MnO4. There is no change in oxidation state of potassium. But permanganate ion, as one more potassium added to the molecule, the oxidation state of permanganate ion has to change from -1 to -2. To adjust the positive 2 charge on potassium, its oxidation state decreased from -1 to -2. So the change in oxidation number of permanganate ion is 1. It means it has accepted 1 electron and reduced itself to oxidize other substance in chemical reaction. So the N factor of KMnO4 in basic medium is 1. But in neutral medium, KMnO4 furnishes manganese oxide. In KMnO4, the oxidation state of manganese was +7. But in neutral manganese oxide, the charge on manganese is +4. So the oxidation state of manganese is changed from +7 to +4. So the change in oxidation state or the change in oxidation number is the mode of 4 minus 7, that is 3. So the manganese accepted 3 electrons, get reduced itself to oxidize other substance in chemical reaction. So the oxidizing agent KMnO4 in neutral medium, it has N factor 3. Potassium dichromate, a good oxidizing agent. In acid medium, it furnishes chromium ion with +3 charge. In the neutral molecule of potassium dichromate, 2 potassium atoms are in +2 oxidation state and 7 oxygen atoms are in -14 oxidation state. Therefore, the oxidation state of chromium is +12. But there are 2 chromium atoms. So the charge on each chromium atom is 12 by 2, that is +6. So each of the chromium atom is undergoing a change in its oxidation state. The charge on chromium atom is decreasing from +6 to +3. So the change in oxidation number is the mod value of 3 minus 6, that is 3. Decrease in positive charge means it has accepted electrons, and gain of electron means reduction. So as a good oxidizing agent, potassium dichromate has N factor 3. Now I would like to discuss with you how to calculate the N factor of reducing agent. Ferrous sulfate. As a good reducer, in presence of an oxidizer, it oxidizes itself and reduces other in chemical reaction. Ferrous sulfate changes to ferric sulfate. Ferrous with positive 2 charge discard electron and become ferric in chemical reaction. Ferric bears +6 charge, but 2 ferric atoms are there. So each of the ferric atom will bear +3 charge. So ferrous atom which is having +2 charge changes to ferric with +3 charge. So there is an increase in oxidation state. Increase in oxidation state means oxidation, and oxidation means loss of electron. So ferrous atom discard electron and changes to ferric. And the change in oxidation number is the mod of 3 minus 2, that is 1. So in chemical reaction, as a reducing agent, ferrous sulfate oxidized itself and reduce other substance. So its N factor is 1. Our next example is oxalate ion. Oxalate ion in basic medium loses electrons, oxidize itself to produce carbon dioxide. The oxalate ion with -2 charge changes to neutral carbon dioxide with 0 or no charge. So the change in oxidation state is from -2 to 0. Its negative charge decreases and positive charge increases, means its oxidation state increase. An increase in oxidation state means oxidation, and oxidation means loss of electron. So oxalate ion discard 2 electrons and oxidize itself to reduce other substance in chemical reaction. The change in oxidation number is the mod value of 0 minus -2, that is 2. So in chemical reaction, oxalate ion oxidized by 2 and reduce other substance. So the N factor of oxalate ion is 2. Now I would like to discuss with you how to calculate the N factor of a chemical species in a disproportionate chemical reaction. Disproportionate chemical reaction is a kind of compact chemical reaction in which the same element undergoes oxidation as well as reduction. For example, I would like to refer hydrogen peroxide. Hydrogen peroxide, on being heated, it decomposes into water and oxygen. In this equation, we see that oxygen is making compound with hydrogen, and also oxygen exists in free state. In this reaction, oxygen has undergone oxidation and reduction both. But how? Let's see that. But first of all, we have to find out the oxidation state of each of these elements. The hydrogen on both sides, reactant and product, it is having last 2 oxidation state. But oxygen, we have to ascertain the oxidation state of oxygen. 2 hydrogen atoms bear 1 charge on each, and assuming the charge on each oxygen atom X, we get this equation. And as this unit is neutral, I am equating this equation to 0. And solving this equation out, we get that oxygen as a reactant is in -1 oxidation state. But in product side, in water molecule, the oxidation state of oxygen is -2, and in free state oxygen molecule, it is 0. So, in one half reaction, the oxidation state of oxygen is decreasing from -1 to -2, means it is reduced by 1, and reduction means gain of electron. So, in this half reaction, oxygen is undergoing reduction. It is gaining 1 electron. And on the other half reaction, the oxidation state of oxygen is increasing from -1 to 0, means oxygen is oxidized here by 1, and oxidation means loss of electron. So, in this half reaction, oxygen lost 1 electron and it is oxidized by 1. So, in the same chemical reaction, oxygen is undergoing reduction as well as oxidation. So, what is the N factor of this chemical reaction? To know that, we have to use one formula. This is one of the formula of calculating N factor. Number of oxidation plus number of reduction is divided by number of oxidation multiplied by number of reduction. And simply by putting all the values for the variables, we get that the N factor of this chemical reaction is 0.5. But it is a incomplete equation. So, to get a complete chemical reaction, we need to balance this equation at first. So, we see that 2 moles of hydrogen peroxide, when heated, it will produce 2 water molecule and 1 oxygen molecule. This is a complete equation. So, for a complete reaction, we need 2 moles of hydrogen peroxide. So, the N factor of an unit formula means 1 mole of hydrogen peroxide is 0.5. So, multiplying this one by 2, we get the N factor of this complete chemical reaction 1. Another example of disproportionate chemical reaction is decomposition of cuprous bromide. When cuprous bromide decomposes into cupric bromide and metal copper, then the copper atom undergoes disproportionation. In this redox chemical reaction, copper has formed compound with bromine, and also it exists as free metal copper. On the reactant side, the oxidation state of copper is +1. But on the product side, the oxidation of copper in the compound with bromine is +2, and in free state, its oxidation state is 0. So, in one half reaction, the oxidation state of copper is reduced by -1, and in the other half reaction, the oxidation state of copper is increased by +1, means it is oxidized by 1. To find out the N factor of copper in this chemical reaction, it is better to divide this complete reaction into 2 half reactions. In one half reaction, cuprous changes to cupric, and the oxidation state of copper is increasing from +1 to +2. Means the copper atom is losing electron and its positive charge increase. But beforehand, we have to balance both the side. So, 2 copper atoms will lose 2 electrons to get oxidized. So, the number of oxidation here 2. On the other half reaction, the oxidation state of copper is decreasing from +1 to 0. The decrease in oxidation state means the atom is accepting or gaining electron. The charge on each copper atom is decreasing from +1 to 0, means the difference is 1, means one copper atom is gaining 1 electron. But we have to balance both the sides. As one copper atom is gaining 1, so two copper atom will gain 2 electrons. So the number of reduction is 2. For this chemical reaction, I like to use this formula that number of participating electrons to be divided by the stoichiometric coefficient. So first of all, we have to ascertain the number of participating electron. Number of participating electron means the total loss of electrons and the total gain of electrons. In one half reaction, 2 electrons are lost, and in the other half reaction, 2 electrons are gained. So we can say that 2 electrons which are lost in one half reaction, those 2 electrons are gained in the other half reaction. So the number of participating electron in this chemical reaction is 2. And as 2 moles of cuprous bromide is necessary for a complete reaction, so for stoichiometric coefficient, we can use this value. So the N factor of copper in this disproportionate chemical reaction is 1. Our next example is chlorine. When chlorine in basic medium decomposes into chloride and chlorate anion, then chlorine is undergoing disproportionation. The oxidation state of chlorine on the reactant side is 0, but on the product side in chlorate anion, it is in +5 oxidation state. So the oxidation state increases from 0 to +5, means it is oxidized by 5. But in the other half reaction, the oxidation state of chlorine is decreased from 0 to -1. It means it is reduced by 1. In one half reaction, when the oxidation state of chlorine is reduced from 0 to -1, it means that chlorine atom gained 1 electron. And as 2 chlorine atoms are there on the reactant side, so after balancing we get that 2 chlorine atoms gained 2 electrons. In the other half reaction, when chlorine forms chlorate anion, its oxidation state increases from 0 to +5. It means chlorine atoms loses 5 electrons, but 2 chlorine atoms are there. So by balancing both the sides, we get that 2 chlorine atoms will lose 10 electrons. So the total number of electrons lost is 10. For this formula of N factor calculation, we have to find out the number of participating electrons and the stoichiometric coefficient. In one half reaction, chlorine atoms lost 10 electrons, but in the other half reaction, chlorine atoms gain 2 electrons. To get the number of participating electrons, we have to balance both the number of oxidation and number of reduction. So to equal the number of oxidation and reduction, we need 10 electrons to be reduced. As one chlorine atom gains 1 electron, so 10 chlorine atoms will gain 10 electrons. But on the reactant side, only 2 chlorine atoms are there. So by increasing the number of chlorine molecule to 5, we can equalize the number of electrons gained and the number of electrons lost. Next, we need to count the stoichiometric coefficient for a complete reaction. In the reduction reaction, 5 molecules of chlorine is used, and in the oxidation reaction, 1 molecule of chlorine is used. So the total number of molecules participated in this chemical reaction is 6, or the stoichiometric coefficient is 6. Now by using or replacing these values in the formula, we get that the N factor of chlorine in this disproportionate chemical reaction is 5 by 3. So now I hope you understand that how is it important to know the calculation of N factor in chemistry. In my next video, I am going to explain equivalent mass and weight, the gram equivalent, and how to calculate them. So keep watching.